Hi guys, this is Math 6, Lesson 1-4, Understand Division with Fractions. In this lesson, we'll be able to use models and equations to represent fraction division. Let's look at Explore It. Students are competing in a 4-kilometer relay race. There are 10 runners. What is a relay race? Have you ever done a relay race or seen one? Yeah, every time in WYS we have a field day, we always have a relay race or some kind of running, right, competition. So if we look at the runners, they have something that they hold on, a baton, and they're gonna hand the baton to the next runner after they finish their part of running. So the entire idea is that it's a group game and they're not running the whole race by themselves, right? So not one person is doing the whole thing. There are other people together in the group to finish the entire race. So in this relay race, we have 4 kilometers and there are 10 runners. And so each runner runs 2 5 kilometers. So 2 5 kilometer is greater than or less than 1? It is less than 1. 2 5 is less than 1. Okay? You're going to divide 1 into 5 parts, and then 2 of that 1/5 part is going to be how much the runner runs for one person, right? And then the next person runs the same kilometers, the next person, and so on. After 10 runners, they'll be able to finish the race. So we're going to use a number line to represent the data for the race. We're going to start at 0 kilometers, finish at 4 kilometers. Let's draw how much each person runs. So we're going to divide this bar 0 to 1 into 5 parts. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Yeah, that gives you 5 parts. Yes, 1, 2, 3, 4, 5. And each runner will run 2/5 of that. So this is one person running. And then the next person runs 2 of that. Then the next person runs 2 of the same thing. So we're gonna divide all these big bars into 5 smaller parts. So 1, 2, 3, and 4 again. 1, 2, 3, 4. 1, 2, 3, and 4 to get 5 equal parts for every bar. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And the next person. And the next person. And the next person. Wait, sorry. That is 3 parts. Whoops. Wait, next person. And then next person. And then next person. And then next person. Next person, next person, next person. Did I miss something? Oh yes, I'm missing a part here. Okay, here. There we go. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay. So part B, use multiplication or division to describe your work on the number line. So how do you describe your work on the number line? What did we do? What does the bars represents? What do the round circles represent, right? So we're going to describe that. Starting at 0, we drew circles, we drew ticks that divide each bar into 5 parts. Then we drew arcs. Arcs to represent each runner's distance. So there are 10 arcs from 0 to 4. There are exactly 10 arcs from 0 to 4. So our work shows that 10 runners, each running 2 1/5 kilometers, will run the 4-kilometer race. And so also we know that 4 divided by 2/5 is 10. Okay, let's look at focus on math practices. Model with math. Describe what a number line would look like if there were 10 runners, each running 1/2 kilometer in a 5-kilometer race. So we're going to do the same thing. We're going to draw 5 kilometer from 0, 1, 2, 3, 4, and 5 to 5. And each runner will run half. So 1, 2, 1, 2, 5, 6, 7, 8, 9, 10. Okay? So this would be what a number line would look like. And so let's describe that as well. We can describe by saying the number line would start at 0 and go to 5. Each kilometer would be divided into 2 equal parts. There would be 10 equal parts. Okay. That was the introduction. Let's move on to the lesson in the next page. So throughout the lesson, think about how we can represent division of fractions. Example 1. Divide whole numbers by fractions. Mr. Roberts has a board that is 3 feet long. He plans to cut the board into pieces that are each 3/4 foot long to build a set of shelves. How many shelves can he make? Okay, so the whole board, entire board, is 3 feet long. And he's going to cut the board into pieces that are 3/4 foot long. So that's dividing 1 foot into 4 equal parts. 1 foot is also 12 inches. That is why we have 12 here. Okay, so if you divide 12 inches into 4, you get 3 inches per each 1/4 of a foot. So 1, 2, 3, and 4, right? And so he's gonna cut each 3/4 long, right? So you also divide this into 4 equal parts, and then you cut 3 of them, and then another one, 27, 30, 33, and 36. And so 3 of them again, and 3 of them again, and that gives you a nice little whole number of 4 pieces. Okay, so one way you can write 3 as a fraction with a denominator of 4 and 12 over 4. Think about division as repeated subtraction, and you're going to subtract 3 over 4 from 12 over 4 repeatedly. And you'll have 4 shelves after you subtract 3/4, 1, 2, 3, 4 times. So if you subtract 3/4, that means he already cut 3/4 feet long of a board. And whatever is remaining is the remaining length. Okay, and then you keep subtracting. Another way, you're going to use a number line to show 3 feet and divide it into 3/4 foot parts. And you'll see there are exactly 4 parts. So you can say Mr. Roberts can make 4 shelves using the number line as well. Now let's try another question by yourself. A board is 6 feet long. How many 2/3 foot long pieces can be cut from the board? You can use the number line to show your work. You have to use the number line. See if you can do it by yourself. Come back when you're ready for answers. Are you ready? Alright, so how would you use the number line to show your work? First, you're going to label it from 0 to 6. And you're going to use the number line to divide it. You want to make 2/3 of a foot. So divide 1 foot into third. Okay? And divide another one. Divide the whole feet, each of the foot, into 3 pieces. And then you're going to count it. 2 each. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So how many parts could we get? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So your answer should be 9 pieces. If you got that correct, good job. Convince me, why is the number of pieces that can be cut from the board greater than the number of feet in the length of the board? Why is 9 your answer? A bigger number than the number of feet in the length of the board. Your board is only 6 feet long. Why is your answer 9, which is greater? Because we're counting the pieces, how many pieces we have. We're dividing it and we're counting how many pieces we have, not the length. We're not talking about the length, we're counting the pieces itself, right? So it could be greater, right? So each piece is less than 1 foot long. So the number of pieces will be greater than 6. We are counting the number pieces, not the distance, or not the length. Okay. Alright, let's look at the next example in the next page. Example 2. Divide fractions by whole numbers. How much cake will each person get if 3 friends decide to share half a cake equally? Find 1/2 divided by 3. So the whole pan represents 1 here. And we have half of the pan. And the friends are going to divide this equally. We have 3 friends, right? So we're going to divide this into 3 equal parts. And so each friend will get this part, which is how much of a fraction of the whole? 1, 2, 3, 4, 5, 6. We have 6 pieces total with the same amount for the whole pan. So it's going to be 1/6 of the original cake. Okay, so each part is 1/6 of the whole. Alright, so let's try the try question. Make a diagram to find 2/3 divided by 4. You need to make a diagram. See if you can do it by yourself. Come back when you're ready for answer. Okay, so first, we're going to divide 1 into 2/3, right? So if you divide this pan into 2/3, we have this part. Let's use a different color, okay? So we're going to divide 2/3 into 4. So we're going to divide this into 4 equal parts. Right? And so we get this one. Yeah. So if we divide the whole thing correspondingly, how many of these do we have? 1, 2. We're not counting the small part. We're counting this whole part, right? So let me put another. So we have 1, 2, 3, 4, 5, and 6 of the equal parts. So this is actually 1/6 of the whole thing. Or if you count it individual parts, your answer, whatever you're shading, is 2 of the 12 small cubes, right? 3, 6, 9, 12. You have, if you counted the small pieces, you should have 2 of the 12 parts, and that is also equal to 1/6. Okay, example 3. Use relationships to divide whole numbers by fractions. You can use what you know about dividing fractions to find and use a pattern. Look at the division and multiplication sentences at the right. Find and use a pattern to solve 4 divided by 2/3. So example 2, we use the diagram, right? But now we're going to look at the pattern and see if we can solve this numerically. So if you look at this table, 8 divided by 4, which is 4/1, is equal to 2. 8 divided by 4 is 2. What about 8 times 1/4 is equal to 8/4, which is also 2, right? 5 divided by 1/2, if you divide 5 into 1/2, you have 10 pieces total. And if you multiply 5 times 2, you get 10. So, and also 3 divided by 3/4 is 4. 3 times 4/3 is 4. Why do we get the same answer? This is a pattern we have between multiplication and division. Two numbers whose product is 1 are called reciprocals. So what is the relationship between these two numbers? They're called reciprocals. The numerators and the denominators are flipped over, right? So if a non-zero number is named as a fraction a over b, then its reciprocal is b over a. Okay? So for the whole numbers 2, you can change that into 2 over 1. And the reciprocal, they're not equal, but reciprocal is 1 over 2. Okay? So if you have a reciprocal, you can change division into multiplication and multiplication into division. This is especially useful for fractions. Okay? Numerically, you need to know how to change between division and multiplication by using reciprocals. So if you have, for example, 4 divided by 2/3, you can rewrite this with a reciprocal into a multiplication, so that is easier to compute. If you change divide by 2/3 into multiply by 3 over 2, then you can just multiply 4 and 3 and 1 and 2 to get 12 over 2. And that is equal to 6. Now let's try this question by yourself. Use the pattern in the table above to find 8 divided by 3/4. What is 8 divided by 3/4? Change it into a multiplication and figure out the answer. Simplify. Okay, are you ready for checking the answer? So if you change this division into multiplication, you rewrite 3/4 into a reciprocal. So change that to 4 over 3. And 8 times 4 is 32. And 1 times 3 is 3. So rewrite that into a mixed number, and you get 10 and 2/3. Okay? So let's summarize the lesson. To divide a whole number by a fraction, you can write the whole number as a fraction and change the division into multiplication by using reciprocal. To divide fraction by a whole number, you can also change the whole number into fraction and use the reciprocal to change the division into multiplication. This is how you can solve it numerically. Alright, that was lesson 1-4, understand division with fractions. If you have any more questions, please ask Ms. King in class. Otherwise, we'll continue with the next lesson in the next video. Thanks. Bye!